Hey guys, hope everyone's doing well. Today we'll be talking about what is the division theorem. The division theorem, or also known as the remainder and quotient theorem, is very helpful to know because it helps you with specific questions. The theorem is n, oh my bad, that is the highlighter. N is equal to dq plus r. And you're probably wondering, what does this stand for? Well, the D here is our divisor. Let me color code this. Q is our quotient, which is this right here. R is our remainder. And N is the dividend. And the dividend is basically what the divisor divides. Before I explain what this theorem is, I want to just make sure everyone knows where all of these stand. So if I do 12 divided by 5, so that goes 2, 10, and 2. This is our divisor. This is our quotient. The 12 here is our dividend. And then lastly, the 2 here is our remainder. Now you might be wondering, well, how does this work? Let's take this example here. Suppose I don't have the dividend with me. So let's just keep that as n. But I do have that the divisor is 5, the quotient is 2, and the remainder is 2. This is given to me. So divisor is 5, quotient is 2, and remainder is 2. So to get the dividend, I would just plug them in. So 5 times 2 plus 2, which is 10 plus 2, which gives me 12. And you can see that's right, according to this example right here. Now let's do some more questions based on this theorem. Our question is, find the greatest two-digit number which when divided by 12 leaves the remainder of 5. Now we simply just have to plug back, but the thing is, we don't have the dividend and we don't have the quotient. But let's start by plugging in what we have. So we don't have the dividend, so let's that be n. We have it's divided by 12, which means 12 is our divisor. We don't have the quotient, and we have the remainder. Now, we have to read the question carefully. It says find the greatest two-digit number. So we know that this can't be greater than 100, because if it's greater than 100, it'll be a three-digit number. So this part has to be less than 100. So now, if I solve this inequality, let me rewrite it here. Times q plus 5 has to be less than 100. So let's subtract 5 from both sides. 12q is less than 95. And q has to be less than 95 divided by 12, which comes to about, I think, 7 and 11 upon 12. So if q has to be less than this, that means that q can be 7. So now that I plug in 7 as q, the greatest two-digit number, which is divided by 12 leaves a remainder of 5, would be 12 into 7 plus 5, which is 84 plus 5, which is 89. And we can always check this by doing normal division. So 89 divided by 12 goes 7 and 84, and we have a remainder of 5. The next question is, how many integers between 200 and 300 inclusive when divided by 8 leaves the remainder of 6? When I tried this question before, I used to get so confused, but now that I know this theorem, it's very helpful. But once again, I want to point out that we have to read the question properly, because it says how many integers between 200 and 300 inclusive, which means that 200 and 300 will be included. This means that our theorem of dq plus r has to be in between 200 and 300, which would be 200 is less than equal to dq plus r, which is less than equal to 300. And make sure you have the equal to, because that plays an important factor. Now let's plug in the values provided. We have the divisor of 8 and a remainder of 6. So 200 less than equal to 8q plus 6, which is less than equal to 300. If I subtract 6 from everywhere, we get 194 is less than equal to 8q. Oh, let me change the color back. 194 is less than equal to 8q, which is less than equal to 294. And then we're going to divide 8 by both sides. So that gives us just 194 divided by 8 less than equal to q less than equal to 294 divided by 8, which is approximately 24 2/8 less than equal to q less than equal to 36 6/8. Now, if I go back to the question and read it, we have to find how many integers. So I can always just avoid this and say that q has to be between 24 and 36, which means that there's 12 integers between there. And we basically got the 12 by doing 36 minus 24, which is 12. And so that means that there are 12 integers between 200 and 300 inclusive when divided by 8, which leave a remainder of 6. Thanks for watching this lesson. If you liked this video, please subscribe to my channel, Algebra Star, or visit algebrastar.com. Once again, thanks and stay safe.